Good evening, math aficionados. This is Victoria, and I'm here to talk about the first section in Chapter 5, which is on factoring. I always think about factoring as most of what mathematicians do can be categorized into two things: breaking things apart and putting things together. And factoring is an example of the first one, of breaking things apart. So in this lesson, you'll learn about how to factor out the greatest common factor, or we call it the GCF, and to factor by grouping. And again, factoring undoes or reverses multiplying. In the two examples that you see here, in the first one, you're going to take the 3x times the quantity 5x minus 2, and you distribute. You multiply the 3x by each one of the terms in that polynomial, and you end up with 15x squared minus 6x. To reverse that process, we want to see, hey, is there anything common in both of these terms that we can remove and factor out, break it apart? And so we look at both of the terms and see what they have. This 15, its prime factorization, if you broke it into its prime, is 3 and 5. And 6, it's going to have a 2 and a 3. So they both share a 3. And they also both share an x. So you can factor out that 3x, and then what you write inside the parentheses is what's left over. So we start with talking about the greatest common factor. It's the largest term that is a factor to all the terms in the polynomial. So we want to look and see not just what they have in common, but the greatest that they have in common. So here, look at example A. I've got 7k plus 28. 7 is a prime number, and the k only exists in that first term. So let's zero in on the second term, 28. 28 is not a prime. It's 4 times 7. So there you have a 7 in each of those. So if we bring out the 7, excuse me, we have 7 times k plus 7 times 4, and we're going to factor out or bring out that common 7, and what's going to remain is the k plus 4. And you can check by multiplying. Second example, B here, we've got 32m plus 24. Neither of these coefficients, the 32 or the 24, are prime. And so we look to see, well, what kind of factors do they share? So 32 is 4 times 8, and 24 is 3 times 8, so they both share an 8. So if I rewrite this as 8 times 4m plus 8 times 3, I can remove that 8, and what I'm going to have left is 4m plus 3. So recognize that what we've done here is we've taken the sum of two terms and changed it into a product and a sum. That's the factorization. In example C, 8a minus 9, there is no common factor because 8 is 2 times 2 times 2, and 9 is 3 times 3. A is only in the first term, so it is already factored. And in example D, we have a 5z plus 5. And often we get confused about when we take out that 5, what's going to be left. Well, it's 5 times z and 5 times 1. So we can remove the 5, and what we'll have left is z plus 1. Now, to get an example that's a little more complicated, now we're going to actually not just have coefficients that are common that we can factor, but we can also have variables that we can factor. So if you look here, we've got the coefficients 25 and 30. They both are multiples of 5. And so they both share a 5. And we have x to the 4th and y to the 3rd. So the largest that they have in common is an x to the 4th and an x to the 3rd. So the largest they have in common is an x to the 3rd. So the greatest common factor, the GCF, is 5x to the 3rd. Look at this step here where you see where I've pulled out the 5x cubed and the 5x cubed, and I've written next to it what's left over. So if you multiply to check, 5 times 5 is 25. X cubed times x is x to the 4th. That works. 5 times 6 is 30. And when we have x cubed, so I have properly factored that out. And then in the final step, I'm going to rewrite what's inside my parentheses. So it's 5x cubed, and then I'm going to have a 5x plus 6. Bravo. More examples. Now notice in example B here, I actually have 3 different terms. So I want to find out what all 3 of them have in common. So I've got coefficient-wise, I've got 100, 50, and 25. And 25 is a factor in each one, so that's going to be the largest one. So if you start with the smallest number, you can check to see if it doesn't divide evenly into the other 2. In this case, it does. And then we have an m cubed, an m to the 4th, and an m to the 5th. So the largest variable term is going to be an m cubed. When we pull that out and see what's left for each term, we're going to have here 25m cubed times 4m squared. Look, that gives us 100 m to the 6th, m to the 5th, minus 25m cubed times 2m, which is going to give us minus 50 m to the 4th, and a 25m cubed times 1. So we write on the outside of our parentheses 25m cubed, and on the inside we'll have 4m squared minus 2m, don't drop that negative, plus 1. And last example, right there, last example, we can have more than one variable, so it can get pretty sticky. Here we've got coefficient-wise 5, 15, negative 20, so the largest of the coefficients is going to be 5. M-wise, we've got m to the 4th, m to the 5th, m to the 4th. M to the 4th is our winner here. And then we have an x cubed, an x to the 6th, and an x to the 6th. Notice that these 2 terms are not like because our m terms don't match. So the largest we have here is an x cubed. When we factor out that of each individual term, we're going to end up with a 1 here. We'll factor out and leave this as 3mx cubed, and then we're going to factor out and leave a 4x cubed. Check it and you'll see it works. And so the factorization of this polynomial is going to be 5m cubed x cubed, 5m to the 4th x cubed, and inside the parenthesis is 1 plus 3mx cubed minus 4x cubed. Now, sometimes when we're factoring, we actually have a binomial that's in common. Look at this example. Notice that we have a product of 2 binomials here plus a product of 2 binomials there. And what we're going to see is, do we have any commonalities? And yes, we do. We have an a plus 2 in this first pair, and we have an a plus 2 in this second pair. So that means that a plus 2 is common to both of them. So we're going to pull that out, and what we have left is a sum, because it's a minus 3 parentheses plus a plus 6. All of that is what's left after we factor out that common binomial. And so we can combine like terms inside of these brackets, and we'll get a plus a is 2a, minus 3 plus 6 is plus 3. And there is your answer. Let's look at another example like that. Notice again that we have a common binomial. In the first term here in example B, we have a y minus 1 times y plus 3 minus y minus 1 times y plus 4. So again, that common binomial, y minus 1, we're going to factor it out. And we're going to take what's left over, put it inside a bracket, and combine like terms. So we have y plus 3 minus y minus 4. Why y minus 4? Because this negative is going to be applied to both terms in the binomial. Be careful. I can't tell you how many times that students leave this as a plus. Once we have it written properly, then we're going to have plus y minus y is going to be 0, and 3 minus 4 is negative 1. So we're going to have y minus 1, that whole quantity times negative 1. And look, we can even rewrite it simpler. We'll have minus y plus 1. So this whole expression up here is going to simplify to this two small binomial here, this binomial here, minus y plus 1. We have to be careful with our negatives. And so here's an example that when you have a negative, and you'll see this in the homework where they ask you to factor it two different ways. You could factor out just the positive variable, or you could factor out the negative variable. And the reason that it's different is that if you leave the negative inside the parentheses, then the negative is going to stay on. Like if we take this r out, minus 6r squared is going to stay as minus 6r, and the 5r will just become 5. So that's one way to rewrite it. If you choose to pull out the negative r, then the sign on both of these terms in the binomial change, and you'll get 6r minus 5. So be careful with these problems. Now, the finale here in section 5.1 is factor by grouping. And I think that in my experience, there's a key. First of all, I'm going to show you what you're looking for so that you know that you're factoring by grouping. And sometimes there's just a little manipulating to get it so you can see that you do have a common product. So it's kind of a fun game to play with this, trying to find how you're going to factor it. Let's look at an example. And see this bold writing here. Factoring by grouping has a certain look. And the look is that you have a polynomial that has 4 terms. 3 or more than 3. So usually it's going to be 4. It could be more than 4, but the most common is going to be 4 terms. So here's an example. Okay, it's a polynomial with 4 terms. I've got 6p minus 6q plus rp minus rq. On the surface, you may not see what's in common. So what is usually the case is you're going to break it into some kind of parentheses. So you can see that we've moved this a little bit. So we took the 6p plus rp, we put those two together, and the minus 6q minus rq. You'll get more comfortable with doing this the more problems that you do. So I have these grouped, and again, I still don't see the relationship. But when I do factor out the p in this first binomial, I have left 6 plus r. And when I factor out the negative q, I'm going to have 6 plus r. So if you can get yourself to this step, if you can find the commonality and factor things out so you have a binomial that matches, then you're going to rewrite this. Notice this. This is the key. You're going to have a P minus Q. You're going to have that binomial times the other binomial, 6 plus R. So the aha moment is going from step 3 here to step 4 when you take it from the factored variable in front of these and then just rewrite it as a product. Let's check another example. All right, again, I've got xy minus 2y minus 4x plus 8. So I'm going to look at this. When I'm eyeballing this and thinking about it, I can see, hey, look, this has a 4 and an 8. If I took those out, what would I have left? It's going to be an x, a minus x plus 2. And then I can kind of see something similar going on here. If I pull out that y, I'm going to have an x minus 2. So the first step we're going to do is we're going to group those two things. Put parentheses around the first two terms, put parentheses around the second two terms, and notice that they chose to factor out a negative 2. This is pretty clear. We're taking out the x. Now, I actually wouldn't have done it this way, but let's go with the way they did it. They're going to factor out an x here, and we'll have a y minus 4, and factor out the negative 2, and we'll have a y minus 4. When you get to that step, then you're going to rewrite this as x minus 2 times y minus 4. And I guess my way of thinking about this is I probably would have kept the groups the way they are here, and I would have factored out the y, and I would have factored out the negative 4, and I would have had left over the x minus 2. So I can see two different ways to solve this, and as long as you get one of them, you will get the right answer. You'll get the same answer for both. So breaking it into steps, that first step, you're going to group terms. Sometimes you have to think about it and look. Sometimes you have to move it a couple times before you find the best way. Then you're going to factor within the groups, and then you factor the entire polynomial. And in the end, you're going to have two binomials multiplied. So again, let's do another example so that we can, and this will be the last example that I'll be posting. We've got a kn plus mn minus k minus m. And if you look at this rather on the surface or even a little detail, I see a k and an m and a k and an m. So that's my clue. So I'm going to group the first two. I'm going to group the second two. This one, I'm going to pull out the n. This one, I'm going to pull out a negative 1. And when I do that, I'm going to have a k plus m term and an n minus 1. Voila. Well, good luck with this section. I will go ahead and post the next section 5.2 as well. Again, I'm here if you have any questions. Thank you for all your hard work. Goodbye.